Welcome to the deep dive. Today we're diving into, well, time, but not just any old time. We're talking about the really big questions about time, the ones that have puzzled like philosophers and scientists forever.
Yeah, we're going to be talking about stuff like, is time actually relative? And do black holes really exist? The way we think they do, at least. And we'll even look at the idea that understanding time is kind of like running a massive video game.
And all this comes from a dissertation by this guy, Craig Wright. It's called Time, the Philosophy of Time.
Yeah, it's a really deep dive into how people have thought about time, like all the way back to the ancient Greeks.
It's amazing how they came up with some of these ideas way back then. Like Diodorus Cronus, he linked time to fate, which
Yeah.
is kind of similar to some much later scientific theories,
Yeah,
right?
yeah, it's like they had this like intuition about how time and all the possibilities are connected.
Yeah, and this idea of a fixed timeline, it
Yeah.
comes up again and again, in philosophy and early Christianity, even in Newton's idea of absolute time. It's like this universal clock that just keeps ticking no matter what's happening.
It's like a comforting thought in a way, right? This like steady, unchanging background to everything. But then Einstein comes along and kind of shakes things up.
With relativity.
Right.
Yeah.
Yeah, with relativity. And he basically says, time isn't absolute at all. It's all warped by gravity and motion and stuff.
Yeah, and that just, it breaks down everything we think we know about time, doesn't it? Like, imagine if you could travel at like close to the speed of light, time would actually slow down for you relative to someone who's just like standing still on Earth.
It's not just a theory either. It's been tested and proven.
Yeah. Which brings us to the whole twin paradox thing. Always blows my mind. One twin blasts off into space at near light speed while the other one stays here on Earth. And when
Yeah.
the space twin gets back, they've aged less than the Earth twin.
Oh.
Crazy, right?
Yeah, it's like they have two clocks running at different speeds, but that's where this Craig Wright guy comes in, and he suggests that maybe we can have both, a universal idea of time, and still have these relativistic effects that Einstein observed.
Hold on. How does that even work? How can you have both?
Right. It's like trying to fit square pegs into round holes. But Wright's idea is to separate the idea of a universal clock tick from the rate of, well, change, or what we call entropy. Like, imagine a messy room. It gets more and more chaotic over time, right? That's entropy.
So in Wright's model, everything in the universe experiences the same universal time, but the rate at which things change, it depends on local conditions.
Yeah.
Like gravity.
Yeah, exactly. It's like you have this universal tempo for a song, but all the instruments are playing at different speeds.
Oh, okay, I kind of get it. But this is where it gets really wild, right? When we start talking about black holes.
Oh yeah, black holes. They're like the ultimate test for any theory about time, right?
They really are.
And Wright actually uses his concept of time to challenge the whole idea of black holes as we normally think about them. These singularities of infinite density where gravity's so strong that nothing, not even light, can escape.
Right, the point of no return.
Exactly. But, there's this thing called Hawking radiation, and it basically means that black holes slowly evaporate over time.
Where they evaporate. Even black holes.
Even black holes, it's mind-boggling to think that even these massive things aren't immune to time, right?
Yeah, it's wild.
And here's the really weird part. As something gets closer and closer to a black hole's event horizon, that point of no return, time dilation becomes extreme.
So you're saying from our perspective, outside the black hole, it looks like the object never actually crosses that horizon.
Yeah, it's like watching a movie scene where the ending just keeps getting slower and slower and slower.
Okay, I think I see where this is going, but I'm going to need a minute to wrap my head around this.
Right.
It's a lot to process.
Yeah, no, I get it. It's like trying to picture a four-dimensional object, right? Our brains just aren't really wired for it. So to make this a little easier to grasp, Wright uses this analogy of the universe as a massive video game.
Okay, now you've got my attention. The universe as a video game. What do you mean?
So imagine the universe as this incredibly complex simulation, and every tick of this universal clock updates everything in it. So different eras of the game, they might run at different speeds, like those varying rates of change we were talking about. But the underlying clock, that universal time, it stays the same for everything.
So black holes, they're like areas where the simulation is running super slow, like
Yeah.
at a lag spike.
Yeah, exactly. It's like everything freezes for a moment,
Right.
but the game's still running in the background.
Wow, that's actually a really helpful way to think about it. But it also raises so many questions, right?
It does. It does. And we're going to get into those questions in part two. We're going to explore some even wilder implications of this whole new way of thinking about time.
Okay, so we've kind of established that this universal clock idea, it's not as crazy as it might sound at first, especially with, with Wright's whole idea about the difference between that constant ticking and the different speeds of change happening everywhere.
Yeah, it's like the universe has got this underlying rhythm, but everyone's kind of dancing to it a little differently.
Exactly. Which brings us back to those black holes.
Oh, yeah.
If we sort of change our perspective and think about them not as these singularities where everything just stops, but like as areas where time is just insanely dilated, it changes the whole picture, doesn't it?
Yeah. Yeah, definitely.
It's like instead of picturing a black hole as this like cosmic garbage disposal where everything gets crushed into nothing, we're imagining it more like a cosmic deep freeze where time is stretched out so thinly that you can barely even tell that anything's changing.
Yeah.
But it's not completely stopped.
Right. Exactly.
So imagine, like, for a second, if you could see things from inside a black hole, you'd see the universe outside just zipping by, like, super fast while you're stuck in this, like, super slow motion.
It's all relative, right?
It really is. But it
Well,
makes you wonder if maybe some of the paradoxes we've always had trouble with when it comes to black holes, maybe they're just because of our limited view of things.
mm-hmm.
Like, if time actually stops at a singularity, how could anything ever fall into it in the first place? Wouldn't it take, like, forever from our perspective?
Yeah, that's a great point. But if we think of black holes more as like these zones of extreme time dilation instead of points where time just ends, it makes a little more sense, doesn't it? Things can still fall in, it just happens super slowly from where we're standing.
So it challenges this traditional picture of black holes as, like, these giant cosmic vacuum cleaners.
Right, exactly.
Which then leads to another interesting question. If black holes are more like pockets of really slow time, what happens to all the information that gets sucked into them?
Yeah.
Does it just disappear forever? That's like that old whittle. If a tree falls in the forest and no one's around to hear it, does it make a sound?
Yeah, and that's where this whole holographic universe idea gets really interesting. If the universe is like a giant simulation, like Wright says, then information is never really lost, is it?
So it's like hitting the pause button on a video game.
Yeah.
Like the information's still there, it's just not being used right now. But theoretically, if black holes eventually evaporate, like we were talking about earlier, all that information would come back out, wouldn't it?
Exactly. It's like hitting play again after a really, really, really long pause. It changes how we think about what it means for something to be lost or destroyed.
Okay, my mind is officially blown. We've gone from ancient Greek philosophers talking about time
Yeah.
to picturing the universe as a giant video game where black holes are like lag spikes.
And we're not even done yet. There's even more to this new way of thinking about time, especially when it comes to stuff like free will and the nature of reality itself.
Okay, well, I need a minute to let all of this sink in, but we'll be right back to dive even deeper into these mind-blowing concepts in the final part of our exploration.
We're back for the last part of our deep dive into time. And man, it's been a wild ride, hasn't it? We started with ancient Greek philosophers, and now we're talking about black holes as cosmic deep freezes and even the idea that the universe might be like one giant simulation.
Yeah, it really makes you, question everything you thought you knew about
Yeah.
reality. But that's what's so cool about exploring these big ideas. You have to confront the limits of what you understand and kind of peek into these possibilities that seem crazy at first. Yeah. And you mentioned earlier that this new way of thinking about time with this universal clock ticking away, it could have some pretty big implications for free will. And that's a topic that always gets people talking. Yeah.
Oh, yeah, for sure. I mean, it's something we all struggle with. Our normal way of thinking about time is pretty linear, right? Like past, present, future. And that makes us think that our choices are creating the future. Like we're steering the ship.
Yeah, like we're choosing our own adventure, right?
Exactly. But if the universe is more like this interconnected web or this simulation where all points in time already exist, that linear model kind of falls apart.
So are you saying that the future is already decided? That
Right.
that our choices are just an illusion? I mean, this is getting pretty deep, isn't it?
I wouldn't say it's predetermined exactly. It's more like all the possibilities already exist within the system, and the choices we make are just determining which path through those possibilities we experience.
Okay, so maybe it's less like a straight line and more like a choose your own adventure book where all the endings are already written, but our choices decide which ending we end up reading. It's still mind blowing, but I guess it kind of fits with the idea that past, present, and future all exist at the same time in this holographic universe.
Yeah, that's a good way to put it. It's just a different way of thinking about time and choice. But it does bring up another question that the people have been asking for centuries, you know. If this is all a simulation, who or what is running it?
Now we're really in the matrix, aren't we?
Yeah, kind of. I mean, this whole deep dive has been like going down the rabbit hole of reality, hasn't it? Like challenging what we think about time and space and even what it means to exist.
So where does this leave us? What's the big takeaway from all this mind bending stuff?
I think the most important thing is to remember that our understanding of the universe is always changing, right? What we think is true today could be completely wrong tomorrow, you know, with new discoveries or new ways of thinking.
Yeah, it is humbling, isn't it, to think we have it all figured out, and then someone like Craig Wright comes along and challenges all those ideas.
Exactly. But that's what makes science and philosophy so exciting. They're always pushing the boundaries and making us question everything and reminding us that there's always more to learn.
So what's next? Where do we go from here?
Well, who knows? But I can tell you one thing, the more we learn about the universe, the more amazing and mysterious it becomes.
Yeah, I'm definitely hooked. I can't wait to see what other crazy discoveries are out there just waiting for us. But for now, I think we've reached the end of our deep dive.
We hope this has made you curious and maybe think about time in a new way.
And until next time, keep exploring, keep questioning, and never stop looking up at the stars and wondering what secrets they hold.